Hi guys, welcome to IB Talks. My name is Federico and I'm the scientific advisor for IB USA. In this brief weekly podcast, we're going to look into interesting and applied research paper in the field of enology. So wherever you are at work or at home, just sit down, relax, have a glass of wine and follow me. Hey everybody, welcome to this new episode of IB Talks. This week, we're going to talk about bentonite and how it affects Sauvignon Blanc aromas. The article, published in the American Journal of Enology and Viticulture in 2016 by Eduardo Vela, is titled Effect of Bentonite Fining of Polyfunctional Mercaptans and Other Volatile Compounds in Sauvignon Blanc Wines. I hope you enjoy it. The appearance of lees or turbidity can often be observed in commercial white wines, primarily because of the presence of tartaric acid salt and insoluble protein. This protein, because of pH or temperature changes from their native state, they unfold and then they aggregate back together, creating bigger clusters that precipitate in the bottle. This problem can be avoided using different fining agents, including bentonite. Due to its low cost, high efficiency, and because it's easy to use, bentonite is currently the most widely used fining agent for protein stabilities. Bentonite consists in a fire laminar structure that contains exchangeable cations, sodium or calcium. These physiochemical properties produce a strong negative charge over a large absorption surface. The mechanism of protein removal is the absorption of the positive protein that are abundant in low pH of wine to produce a complex that will flocculate and settle. The first disadvantage of the use of bentonite is the amount of sediment produced. Both sodium and calcium bentonite usage can lead to substantial wine losses. The second one is the change in texture and flavor, which has been correlated with the amount of bentonite employed for stabilization and is dependent on a direct absorption or an indirect mechanism. Discrepant results have been reported on the best usage of it. The use of bentonite in mast may favor sedimentation of suspended solid while promoting mast protein stabilization, therefore being more efficient and reducing loss of aromatic compounds. Adding bentonite during fermentation has been reported to require minimal amount and removal of aromatic compounds is apparently lower. Other research instead shows that the best addition is in the finished wine. The project had two goals. First one was to establish the optimal timing for bentonite addition, and the second one was to assess the effect of the bentonite on the aromatic compounds, in particular the polyfunctional mercaptans that are also called varietal thiols. Therefore, the grape variety chosen was Sauvignon Blanc because of its high content of varietal thiol that gives its distinctive aromas described as green and tropical. And the second reason was because if the protein content is high, this variety tends to exhibit protein A's. The experiment was done over two vintages, 2014, 2015, and the fermentation were carried on in 10-liter tanks at a temperature of 65 Fahrenheit. The control had no bentonite addition, while the treatments had different rate of bentonite addition at the beginning or at the end of fermentation. The effect of the bentonite addition was assessed only with stable wine. Table 1 shows that, as expected, the increasing amount of bentonite adding to the mast in fermentation decreased the turbidity of the finished wine. However, in both vintages, 100 grams per hectoliter of bentonite was required for protein stability, therefore an NTU difference less than 2. For the wines obtained without any mast treatment, This concentration was lower at 75 grams per hectoliter in 2014 and 50 grams per hectoliter in 2015. The data indicates that fining in must was less effective than in wine because higher concentration of bentonite were required when the addition occurred at the beginning of fermentation. Bentonite also had no influence on the conventional enological parameters, tartaric acid instabilities, and organic acid concentration. Bentonite treatments have no real impact on ethyl ester and acetate, carbonyl compounds, and long-chain fatty acid, which showed no significant difference or no clear trend after the addition. Instead, a reduction in the terpenes was measured, probably due to a loss of their precursor, which is irrelevant to the aroma of Sauvignon Blanc, but it could be relevant for other grape varieties. Also, a reduction in phenols has been measured, and the concentration of 4-vinyl guaiacol and 4-vinyl phenol was from 11 to 28% less. 6 varietal thiols were determined, and a similar pattern has been observed. The content in the finished wine addition was affected by the bentonite treatment, but the loss was lower than the initial addition. An explanation can be a strong interaction between the bentonite and the varietal thiol precursor, or another one could be an interaction between the bentonite and the yeast enzyme responsible to release the varietal thiol from their precursor. The conclusion of the author is the bentonite fining modified the volatile composition of the bottled wine, but the modification depended upon the chemical family, the vintage, and the timing of the bentonite addition. Bentonite was more effective for protein removal when added in the finished wine, while adding it at the beginning had a positive impact in the reduction of volatile phenols. Regarding the thiols, using it in finished wine could be a better option. This is it for today's presentation. If you like to see more of these videos, please subscribe to our YouTube channel or newsletter. If you like to have more information of IAB fining agent, please contact your local sales representative. Stay safe, stay connected. My name is Federico, and this was AB Talks.